This video is on quality control rainfall data. This is the 8th in the R-Instat series on climatic analysis. The last video looked at temperature data, and here we see what is possible with rainfall. Data from 2 stations in Ghana in the R-Instat library are used for illustration. It is useful to know how the rainfall data were computerized. The data entry to ClimSoft is shown here. The paper forms usually include the monthly rainfall totals calculated by hand, and that's used as a check. An alternative is to enter the data twice and then to compare the 2 copies. Go to Climatic, check Data QC Rainfall. The fields should fill automatically as they did with the temperature quality control dialog. If not, then either you are in the wrong data frame or your data were not defined as climatic. However, rainfall is a different sort of element than the temperatures. There are many zeros and occasionally very large values, so fewer checks are possible. Start with the range test. This gives a new data frame with just 1 day over 200 millimeters. There were therefore no negative values in the data and 1 day of 215 millimeters in 2005. That's entirely possible. Return to the dialog. The second check is for repeats of the same value. For the temperatures, the default was 4 consecutive days the same. For precipitation, the default is 2 days with identical non-zero values. There are 222 days to examine, so about 110 occasions. To look more easily, delete the variables after the rainfall. Most of the repeats are very low values, and perhaps that's not surprising. Filter to just the rainfalls more than 1 millimeter. There are now 30 occasions with repeated values and just 1 case of 3 consecutive days with the same value. Scrolling down, look at the repeats of 18 millimeters in April at Tamale. This is not impossible, but does look surprising. One possible reason is that the value was initially put on the wrong day. Then it was corrected, but the original was not deleted. These and the other examples could usefully be checked against the original paper copy of the data. The next check is on the occurrence of a large sequence of consecutive rain days. There are 4 occasions with more than 10 consecutive rain days, and all are within the first 5 years at Salt Pond. Looking in context, the last sequence extended from the 14th to 28th June 1949. This looks as though it could be all right. Occasionally, the values are all similar, perhaps all around 20 millimeters, and this then turns out to be the temperature data of around 20 degrees that were entered in error. We show in the new variable here for illustration. Return to the dialog and choose the dry month option. Click on the Omit Months button and check January, February, and November and December. Then press OK again. The results give 248 rows of data. That's 8 months when you divide by 31. Right-click in the month variable and choose the Label/Labels dialog. This indicates August and October in 1 year each and March 6 times. In the dialogue, we omitted November to February because that's the dry season. So those months being dry will be no surprise. Back to the data shows August 1958 at Salt Pond was dry. That's plausible because the pattern is biomodal there and August is the main between month. Scrolling down shows October 1971 was dry at Salt Pond, which is a bit surprising. The main purpose for this check is that a missing month may mistakenly be entered as a sequence of zeros. Here, for example, if June had been a dry month, that is almost certainly an error. Leaving it in the analysis creates an erroneous very long dry spell in that year. Hence, this should be checked back to the original data. So, here we would like confirmation that the October 1971 rainfall at Salt Pond was really all zero. The final check of the rainfall data is an adaptation of the outlier checks for box plots. We didn't use box plots for rainfall data in the earlier video because they are not intended for really skewed data. Here, they are for the Ghana non-zero rainfall data. However, there is an R package with a robust adaptation of box plots. We have yet to implement the graph but can locate the outliers here. Looking back at the box plots, why were these two values singled out as being the most extreme? This shows that most rainfalls at Salt Pond in August or September are quite low. Hence, those two values are more surprising than larger rainfalls in a different month. In a supplementary video, we consider how to deal with the oddities in the data that have been found. There is another on quality control for other elements.